In this lesson, we're going to learn about segments and congruence. So your learning goal is I can use segment postulates to identify congruent segments. So today we're going to learn about what a postulate is. The difference between that and theorem is subtle but important. So go ahead and copy down this diagram here in your notes. So it's a line with points A, B, and C, all collinear, and a non-collinear point D. So over here, this paragraph says the blank of segment AB, and this is saying the measure of segment AB is written. So the measure means its length. So the measure or the length of AB. So AB, segment AB itself is a geometric figure, but the measure is the length. So that's written as just AB without the segment symbol on top of it. So whenever you see AB with the segment on top of it, that's denoting the actual segment in the diagram. AB without the segment symbol on top of it is the length. Or like how many units, like 6 inches or something like that. So it's written AB and is the distance between the points A and B. To find the distance, either count the positions between the 2 points or take the absolute value, in other words, subtract of the difference of the coordinates. Because you can't absolute value because you can't have negative length. So no negative length. Length can only be positive, so you have to take the absolute value of it. Okay, and then the other point here is that point B is between A and B because A, B, and C are collinear, and B is between A and C. Okay, that's pretty obvious. D is not between A and C because A, B, and D are, like we said, non-collinear. All right, so here, a postulate is something accepted to be true without proof. Theorems, on the other hand, require proofs, but a postulate does not require it to be proven. That may not seem very important right now, but further down the line, when we start learning about theorems, that this fact here is going to be important to us because we can use postulates to help prove our theorems. Okay, so that'll be more important down the line. And then 2 segments are said to be congruent. This is probably a word familiar to you. Congruent means that they have the same measure, or this, remember, measure also means length, so the same length. So this is very important. Here we say that segments are congruent, and measures are equal. So you only say that a figure is congruent to another figure, so the shapes are the same. But when you're talking about the length of the segment or its measure, then you say that the lengths or the numbers are equal. So the symbol for congruent is this marking here. So it says you can say that AB equals CD, or segment AB is congruent to segment CD. So the symbol for congruence is an equal sign with a squiggle over top of it. So you say the lengths are equal, but the segments are congruent. So in other words, you cannot say that the lengths are congruent because we're just talking about numbers here. Numbers aren't congruent, numbers are equal. And then the length, or the segments themselves, the figures, they can't be equal, they have to be congruent. So don't write it like this. This would be the correct way to write the difference between equals and congruent. All right, so next section is about the segment addition postulate. So this is a really important postulate that we'll be using all throughout the year. So it's a good starter postulate. So go ahead and draw in this figure, this line here, with points P, Q, and R. So the segment addition postulate basically says that when you have 3 collinear points and you know that Q is in the middle of P and R, then we can say that the length of PQ plus the length of QR is equal to the whole thing, the length of PR. So we can add up the segments and then they will be equal to the entire segment, okay? It doesn't matter where Q is in between P and R. It could be closer to P, it could be closer to R, but you just know that if you did split them in half, split them into 2 pieces, don't have to be equal. If you put them back, they'll end up being the whole piece. So it says if Q is between P and R, then, okay, that's just what we said. So P, R. All right. So we're going to skip that page. This is technically number 1. We're just skipping 1 through 5 because it's kind of self-explanatory. So find Km. So obviously, you would just add these 2 numbers up and that would give you the answer. But if we were to formally use the segment addition postulate, we would say that we would always start with the geometry. So KL plus LM equals KM. So after you write an equation for the geometry, then you can replace it with the algebra or the numbers. So we'll replace KL with 24, LM with 12, and then we can evaluate. That would give us 36. So KM is 36. Find ST. Okay, so ST is this part. So here we would say that RS, based on the segment addition postulate, RS plus ST is equal to RT. So we'll plug in what we know. RS is 18. ST, you could just leave it as ST or you can write X. RT is 37. Okay, and then it's an equation, subtract 18. So X is, what, 19? Or ST is 19. Okay, so obviously for that one, you could do this in your head by just subtracting 37 minus 18. Do you need to show all this work? Not necessarily, just keep in mind that this is what you're actually doing when you're solving this problem. All right, number 8. So number 8, we've got all sorts of expressions here. So we can say, first, based on the segment addition postulate, Mn plus Np equals Mp. And then plug in the expressions. X minus 5 plus 3x plus 2 equals 6x minus 23. Okay, so now just simple algebra, combine like terms. X and 3x make 4x. Negative 5 plus 2 is negative 3. I'm going to subtract the smaller x. So negative 3 equals 2x minus 23. Add the 23 over. Oops. Here we go. So that gives you 20 equals 2x. X equals 10. Now, hold on. Did it ask us to find x? Let's look at the top. No, it says to find NP. So NP is 3x plus 2. So if we want to find NP, then we have to plug in our answer. of 10 into 3x plus 2. So 3 times 10 plus 2 would give us 32. So NP is 32. All right, so find LM if L is between N and M. All right, let's draw a diagram. So we've got, obviously we have a line here, and it says L is between N and M. So L will be somewhere in the middle, and then N can be over here, N can be over here. This is not drawn to scale. I don't know what the scale is, but this would be a good picture, as long as L is between M and N. All right, so it says NL is 6x minus 5. I'm going to write that in the diagram. LM is 2x plus 3, and then the whole thing is 30. All right, so starting from the geometry, we know that ML plus LN equals MN. And now let's plug in the expressions. So 2x plus 3 is ML, plus LN is 6x minus 5, and MN is 30. Combine like terms and solve for x. But remember that we might not be asked to find x. We might be asked to find something else. And we're supposed to find LM, so just keep that in mind. All right, so combining x's would give you 8x. Combining 3 and negative 5 would give you negative 2. Add the 2 over, and then that means x is 4. So if x is 4, we'll find LM by plugging in 4 into the expression for LM, which is 2x plus 3. So that gives us 2 times 4 plus 3. 8 plus 3 is 11. Awesome. And then this one here. Find NL if L is between N and M. Okay, so kind of similar. So same picture, right? We have M, L between them, and N. And then we're just trying to find LN. Okay, so kind of similar setup. NL is 4x minus 2. NM, the whole thing, is 12x plus 16. And LM is 2 times 5x plus 2. All right. So I think we've got the algebra part. Algebra part is the same. I'm just going to go ahead and plug in our expressions for the algebra part. That was from over here. So ML is 2 times 5x plus 2. Note that we're going to have to distribute the 2 for the first step. And then plus 4x minus 2 equals the whole thing, 12x plus 16. So first, distribute the 2, get rid of your parentheses. 10x plus 4. Okay, combine like terms, solve for x. 14x plus 2 equals 12x plus 16. Okay, rearrange your x's in your numbers. So you get 2x equals 14. So that means x is 7. And if x is 7, we're trying to find NL, right? Yes, so NL equals 4x minus 2. So 4 times 7 minus 2 would be 28 minus 2, which is 26. So that's your answer for that problem. Okay, so a little challenge problem here. This says if CD, go ahead and take a minute to copy this example down in your notes. It says if CD equals 10, so CD is 10, BD is 18, BD 18, Okay, so if you know that BD is 18, now I'm not going to tell you the answers to these ones because I'm going to put this as an exit ticket. Think about what else you know. If you know that BD is 18 and CD is 10, okay, so think about what else you know. All right, so we've got, oh wait, yes, so we've got this down. GJ says GJ is 22. So GJ is right here. We know that's 22. And then BG is 34. So where is B? So all the way from B to G is 34. Well, you should have been able to you should know what BD is, right? That's 18. So now you can figure out what DG is, knowing that the whole thing is 34. Okay, and then AB is equal to BC, which is equal to EF, which is equal to GH. So let's mark those segments congruent. So to mark a segment congruent, you put a little slash through it. So AB is equal to BC equal to EF equal to GH. Well, you already figured out what BC was, right? Back at the beginning. So that means that's the same as AB, EF, GH, which can help you figure out what HJ is. So look at the last thing. It says DG equals GF. So DG equals GF. So knowing DG from previous example, you can also figure out GF. Right, so I've walked you through this problem. I've given you some hints. Now I'm going to let you take it as an exit ticket.